We're being joined by Georgi Dinkov. I've learned so much this year. He's just opened my eyes to so many foundational basics. He basically learned the biochemistry by himself, which is an amazing testimony to that you can do this yourself. And the reason I want to share that, it's so critical you understand this, because the information is there. All you have to do is put in the time and effort. And my nickname from Georgi from the last time is the fire hydrant, because he's just a flow of incredible insights.
The rate of living theory, which is really underpinning this whole concept of oxidative stress. Currently, pretty much every doctor you pick, try to talk to about aging, they'll tell you that, look, the higher your metabolic rate is, which means the quicker the electrons move from food towards oxygen, which is the final acceptor of electrons, the quicker this process is. Basically, the faster you will age, because there will be higher oxidative stress. You'll be producing a higher amount of reactive oxygen species. But if you look at the actual data, and actually this is even in the medical books, it turns out it's the exact opposite. Reactive oxygen species get generated. Yes, they are generated from oxygen, but it's actually when you're not shuttling the electrons fast enough towards oxygen. If you look at this, what a reactive oxygen species is, you will see that it's actually oxygen that has been reduced. In other words, oxygen that has gained an electron. Now, electron by its nature is a reductive species, right? Basically, a food is a donor of electrons, a reductant. Oxygen is an acceptor of electrons, an oxidant. So if you have a buildup of electrons, this means that you're in a state of excessive reduction, or at least higher than optimal. So these electrons have to do something. The body has to do something with them. You're giving the body electrons either from food or through lipolysis or the cortisol generating, amino acids from your muscles. Ultimately, all of these things get converted to energy. And the way energy works is it's a flow of electrons. So electrons ideally should be paired at the very end with oxygen through complex 4 of the electron transport chain. And if that does not happen, then oxygen, molecular oxygen floating around, these electrons can actually attack it and reduce it by an electron or two and generate these very reactive species.
Now I want to jump to a really complex concept that is antithetical to almost every conventional medical person. And that is the concept of reductive stress. And I actually remember viewing a podcast you were on with Tucker Goodrich and Kate Shanahan, where you were discussing this concept. And Kate's a pretty sharp woman. She's one of the first people I ever interviewed about the dangers of linoleic acid. But she just couldn't get her head behind this concept. She was just adamantly opposed to reductive stress as a concept even. And she didn't believe it. So I think we need to, it would be really helpful to understand this, because this is really mind-bending, and it absolutely turned my world upside down once I understood this thing with respect to what I thought and believed to be the truth about really the fundamental way that we age in an accelerated fashion. It's believed to be oxidative stress, and then further refined to be oxidative stress in the mitochondria. And yes, because that's where most of it occurs. But when I wrote my book, Fat for Fuel, I was totally mixed up. I thought fat was the cleanest fuel. And it turns out, no, the cleanest fuel is when you have reductive stress minimized. Because reductive stress, now, first of all, we'll define it in a moment, but it actually is what causes oxidative stress.
Yep.
So to understand it, you have to understand what is oxidation and what is reduction. So why don't we go over this simply, because this is a complex topic, and I suspect many of you will need to listen to this a few times to get it, or you can just fast forward if you don't want to. But in my view, it is really foundational to understanding what's going on. And once you understand how to combine these other components, you can easily refute any of the arguments that people have against this, because it's so solid and really explains at the fundamental submolecular or subcellular molecular level in the mitochondria what's going on and why it's going on. And it's pretty straightforward once you understand the basic concept.
So I guess we can start with the rate of living theory, which is really underpinning this whole concept of oxidative stress.
Mm-hmm.
Currently, pretty much every doctor you try to talk to about aging, they'll tell you that, look, the higher your metabolic rate is, which means the quicker the electrons move from food towards oxygen, which is the final acceptor of electrons, the quicker this process is, basically the faster you will age, because there will be higher oxidative stress. You'll be producing a higher amount of reactive oxygen species. But if you look at the actual data, and actually this is even in the medical books, and I send you Wikipedia pages about this, it turns out it's the exact opposite. Reactive oxygen species get generated. Yes, they are generated from oxygen, but it's actually when you're not shuttling the electrons fast enough towards oxygen, when these electrons build up in various chunks of this process, whether it's the Krebs cycle or the electron transport chain, and these electrons, which are coming from food, you have to do something with them. And the body has...
Let's stop here. What you just said is a profoundly important statement. And I am wondering why this isn't more widely known, because I was searching for this information and I never found it. I couldn't find it anywhere. I was trying to find out where are most of these ROS generated in the mitochondria, and it's not clear. But if you understand the concept, you can see it. So how did you understand it, and why? What is the reason why this isn't more widely known or certainly accepted?
Well, I think the main reason is that basically if you use the various search engines, they're going to give you what the majority of the websites are writing about. Just like the AI, the chat GPT part. If you try to argue with it on a specific medical topic, it will just argue blindly, I mean, to the death, that a specific concept is what medicine says, and no amount of evidence you produce will convince it otherwise. It'll say, this is my model. That's all I understand. So if 99% of the websites and medical presentations and studies are saying oxidative stress happens only in the context of high oxidative metabolism, then if you search Google, then the first 5 or 10 pages will be basically statements along that line. But if you look at this, what a reactive oxygen species is, you will see that it's actually oxygen that has been reduced. In other words, oxygen that has gained an electron. Now, electron by its nature is a reductive species, right? Basically, a food is a donor of electrons, a reductant. Oxygen is an acceptor of electrons, an oxidant. So if you have a buildup of electrons, this means that you're in a state of excessive reduction, or at least higher than optimal. So these electrons have to do something. The body has to do something with them. You're giving the body electrons either from food or through lipolysis or the cortisol generating, amino acids from your muscles. Ultimately, all of these things get converted to energy. And the way energy works is it's a flow of electrons. So electrons ideally should be paired at the very end with oxygen through complex 4 of the electron transport chain. And if that does not happen, then oxygen, molecular oxygen floating around, these electrons can actually attack it and reduce it by an electron or two and generate these very reactive species.
Well, let's stop here, because this is complex. And you said these electrons floating around. So I'm assuming they're floating around in because there's essentially 5 complex.
Well, they're moving. I shouldn't say floating. They're actually moving along the steps of the metabolic chain.
1 to 2 to 3 to 4 to 5. And in that process, and you'll go in a moment, if you don't have those cofactors, it gets stopped.
Exactly.
And flows backwards.
Exactly. So if they can go forward, they can build up. And when they build up to a certain point where it becomes toxic for that specific step, the step will say, I have too many. Send them backwards, right? And then by sending them backwards, basically, they can interact with the molecular oxygen, which is always there, but it's only useful if it's used at the last step, which is the cytochrome C oxidase. At any other point, oxygen coming into interaction with these electrons is asking for trouble. It's basically like similar to the peroxidation of the polyunsaturated fats. You can either degrade them oxidatively, which is still not preferable because we're going to talk about oxidative stress, reductive stress, right? But they can, if they don't get properly metabolized, they can get attacked by these reactive oxygen species and create a degenerative free radical or basically a toxic aldehyde. So the same thing happens with these electrons. When they're not meeting the oxygen at the very end, they build up at complex 1 or 3 usually, right? And then this excessive buildup of electrons, the body has to do something with it. And when it loses control, when these electrons build up too much, then they start leaking through the mitochondrial membrane and start combining with molecular oxygen and creating reactive oxygen species. However, these oxygen species are not oxidative. They're not oxidizing agents anymore. They have accepted either 1 or 2 electrons, so they're actually reductive species. So the hydroxyl radical, which is the most powerful one we produce, and the superoxide anion, which combined, these two are probably responsible for the 90% of the reactive oxygen species. Both of these are reductive agents. They're 1 electron reductive agents. So they can attack the DNA in our body, they can attack the polyunsaturated fats, they can attack various enzymes, including the actual electron transport chain enzymes that are there, or the cardiolipin, which is part of the electron transport chain 4, right? But they're not oxidants themselves.
I thought cardiolipin was a fatty acid embedded in the inner mitochondrial membrane, and it's not.
It's part of complex 4.
I thought it was part of the cristae that can convolute.
Yes, but complex 4 cannot work without combining with cardiolipin. So cardiolipin is crucial to the final step of oxidizing cytochrome, which is being reduced by complex 3, and so without cardiolipin, complex 4 will not work. So yes, not fused with it, but the final step of accepting the reduced cytochrome C from complex 3 and oxidizing it to complex 4 requires cardiolipin as present. And cardiolipin, since lipin is in the name, is composed of lipids. And if we eat too much PUFA, you get too much PUFA in the cardiolipin. And all of these reactive oxygen species, they're highly reactive, but they're not oxidants. They're actually a reduced form of oxygen. So they're highly reactive. They can cause wreak a lot of havoc. But the very reason they're present there is because there was an excess of electrons to start with. And an excess of electrons is by definition a reductive state, right? That is at the core. So having a high amount of excess unpaired electrons means you were in a reductive state or reductive stress, if you want to call it, right? And only then you can have the oxidative stress, the creation of the reactive oxygen species, which for some reason became termed oxidative stress, as if it was the oxygen causing this. It's not the oxygen causing this. Oxygen by itself floating around in the mitochondria does not do much damage as long as the electrons, in other words, the reductants, are flowing along the line as
it's just like the carbs in diabetes. Carbs are getting unfairly vilified. They're just like an innocent bystander.
Innocent bystander, yeah.
The damage that's going on. But I just want to highlight, you sent me this email this morning that my mind was just spinning because I never knew this was true, is this, when these cofactors, and you're talk about that next in a moment, they're diminished and the electrons can't flow all the way to complex 4 to get attached to oxygen. That's like 0.1% ROS per second, 0.1%. Yeah. Whereas if it goes backwards, reverse flow and blocked, it's 3 to 4%. So this is such a massively important concept to get.
Yeah. So the higher metabolic rate, the more easily these electrons flow from food to oxygen, the less oxidative stress. I know it's a misnomer, but let's use it. The less oxidative stress you're going to have. The slower your metabolic rate, for whatever reason, this immediately translates into buildup of these electrons, combining with oxygen and creating these reactive oxygen species, which for some reason medicine has called oxidative stress. It's not oxidative. It's a damage caused by excessive state of reduction, right? It's too many electrons that are unpaired. And as even the Wikipedia articles that I sent you said that the determining factor for most of the creation of the reactive oxygen species is the NADH to the NAD ratio. NADH being the reduced form, NAD plus being the oxidized form. So this ratio, which also controls the speed of metabolism of carbohydrates, because the rate limiting step is pyruvate dehydrogenase. When you're in the oxidized state, in other words, NAD plus predominates, then pyruvate dehydrogenase works well, and then basically these electrons start flowing through the Krebs cycle and also the electron transport chain emitting oxygen. When NADH predominates, which means you have too many electrons, that's what NAD does. It accepts a hydrogen, so now it's a carrying of extra electron. So when you have too much NADH, means you have too many electrons that are not meeting oxygen properly. This buildup of electrons creates these bottlenecks, right? Either complex 1 or complex 3, mostly. It can happen in the other ones as well. And then something has to happen with these electrons. Two things can happen, actually. One is increased synthesis of the reactive oxygen species. Second is the body uses these extra electrons to synthesize fats. So you can view obesity, or at least extreme obesity, as a desperate mechanism to get rid of electrons that are coming from food but are not getting properly. In other words, you're not combusting the food properly. So what happens with it? Well, you store it, right? That's the only thing that the body can do. And the second thing, and by the way, they always happen hand in hand, always happen together, is whenever you have obesity or overweight, severe overweight, you always have high amounts of reactive oxygen species, because those are the only two things that the body can do with the extra electrons. It cannot simply evaporate them, though there's some research on grounding that I think it can actually help get rid of the excess electrons.
I was going to ask you about the grounding, if that was...
I think it's promising.
Because to me, superficially, it appears to be another reductive stress, because it's a source of electrons, and that's the issue, in excess electrons.
Well, some studies are saying actually, because when they measured the electron potential of the blood, and they didn't measure NADH to the ADH ratio, but basically they said that when people were grounded, they were actually losing the excess electrons. So,
oh, interesting. Okay, because I mean this information I was studying before would suggest it was the exact opposite, but it makes sense. You're just like, if you're dissipating static electricity.
Exactly. Precisely. Which is, but the static electricity is an excess of electrons, right? So, so you're discharging them somehow. So really, basically, like I said, the two things that the body can do with excess electrons, which by definition is a reductive state, or let's call it reductive stress, is dissipate them through either synthesizing fats or creating these reactive oxygen species. Not that the body wants to, but if the electrons are not being processed properly, they will react with molecular oxygen and create those reactive oxygen species, which then the body has to somehow deactivate, and it's got a number of different enzymes, right? Or you can take antioxidants. But the whole point is, before you even get to that point, why bother taking all of these substances if the whole problem from the very beginning was the metabolic rate, like the metabolic process, was not working as fast as it should have. So the way to get rid of oxidative stress, paradoxically, is to increase oxidation, to increase the metabolic rate. That's really the ultimate antioxidant, is improving metabolism. Now, if that doesn't work, or you're not doing it for whatever reason, sure, antioxidants can help by neutralizing many, if not most, of the reactive oxygen species. But if you haven't addressed the blocks that are the reason for these reactive oxygen species, this means they will always be produced. So you always have to be taking antioxidants. Really sounds like a suboptimal thing. It's like, I keep cutting you with a knife, and instead of really, stitching up the wound, right, I'm going to give you painkillers so you don't feel that the wound is there. It's not really, the solution. You're just masking up the problem by taking continuously the antioxidants. Now, doesn't mean that it's not a valid approach, right? If you have a lot of PUFA, right, or if you've been, under oxidative stress for a very long time, but it's not the actual solution to the problem. The solution is improve metabolism so the electrons go where they should be going, that they don't build up.
Yeah, and that's exactly what Ray Peat's work is all about. The fundamental core is pro-metabolic work, is to improve your metabolic rate.
Yep. So the analogy that he gives is with the light bulb. Light bulb is between the two poles of a battery. One pole, we are the light bulb. And the intensity of the light is the intensity of our metabolic rate. And the intensity of the light depends on how quickly the electrons can flow from one pole to the other through the light bulb. Let's say if the light bulb is made of the conductor, it has very high resistance, then the light will be dimmer, and it will be producing a lot of heat, and eventually the light bulb will burn out. But the light bulb works best when there's very little resistance and the light is as bright as possible, which means the electrons are facing very little resistance in this object that is staying on their way between food and oxygen, right? The two poles of the battery. So the less resistance, the less problems we're causing to the electrons on their way from food to oxygen, the healthier we'll be.
Yeah, that's just amazing. So I'm sure, thank you for sharing that. It was just brilliant, and it was actually pretty well simplified. I mean, it's a complex topic, but you did a magnificent job of simplifying. That's the best I've ever heard you say it. And so I'm sure anyone listening to this is really excited about learning how to reduce the reductive stress. So let's go over the big ones. I think, and maybe rank order them as the most important. Would PUFA elimination be the most important thing to reduce the oxidative stress or reductive stress? Sorry.
Well, I think as a very immediate thing you can do is take some oxidizing agents, right? If you have a buildup of electrons that are not meeting oxygen, things like quinones, like coenzyme Q10, which is, by the way, a component of complex 2 and 3. Sometimes you get buildup of electrons because of coenzyme Q10 deficiency. Guess what? Taking statins reduces your ability to synthesize coenzyme Q10. So you would think that people taking statins will have higher amount of reactive oxygen species, and that has been confirmed universally among many other issues that people taking statins face. A reduced molecule cannot accept electrons, but it can actually neutralize the already formed reactive oxygen species. So really the better thing to do is to take the oxidized version, which will help prevent the buildup of electrons to start with. And that will also potentially eliminate the problem with the synthesis of fat. Remember, the antioxidants, once you take them the reduced form, they only address the reactive oxygen species. They don't address the other pathway through which the body gets rid of excess electrons, which is the synthesis of additional fat. While the quinones, the oxidized molecules, the oxidizing agents, will actually solve the problem at the very beginning, which is if there is a block somewhere along the steps, most quinones can actually take this extra load of electrons to themselves and relieve the block a little bit.
So another quinone would be vitamin K2, right?
Yes, vitamin K2 is a quinone. Methylene blue, which you mentioned in your email, is another one.
Oh, methylene blue. We're gonna I guess we could talk about it now. I'm a huge fan of methylene blue.
I mean, it's a quinone-like molecule. It can accept 2 electrons, and basically it can be cycle redox, so you can then donate them to another portion, right? Then come back, pick up another 2.
It's the parent molecule for hydroxyquinone or hydroxy.
Quinine.
Yeah,
quinine is the parent molecule for hydroxychloroquine, which was used for COVID.
No, but I thought, wasn't the quinine a derivative, a non-staining derivative of methylene blue?
Let me see.
That was my understanding. It was derived that they got the quinine that was developed specifically because they didn't.
Yes, because they were doing they were isolating the quinine molecule, and the person who discovered methylene blue then patented it for malaria. It was like a German scientist, I think, in the 1860s.
Paul Ehrlich, I think.
Yes, exactly. Yes. Yeah. So they're structurally similar. I didn't know, actually. I learned something every day. I learned something every day. Yes, they're structurally very similar, but the quinine is colorless, while the methylene blue in its oxidized form is actually very deep kind of blue.
But if it's reduced, it's colorless.
It's colorless, exactly. Yes. And there is a company doing research with reduced methylene blue that is now developed a cream, anti-aging cream, that you apply to your body, and basically by improving the metabolism, by improving the flow of electrons, they're saying they're capable of reversing skin aging in humans.
Yeah, I remember reading that. It was in Nature it was pre-COVID. It was like 2018, I think. That paper. But methylene blue, you wouldn't want the reduced version normally because it's not going to help reductive stress. But the beautiful thing about methylene blue, and this is where I was hoping you can clarify this for me, is because it's can be oxidative or it can be reductive.
Yes, you can go back and forth. Well, most of the antioxidants, if they either donate or accept the electron, they're done. So they're done. You have to excrete them and get a new one. But methylene blue can go back and forth for a long time. I mean, half-life is, I think, like 36 hours.
No, I think the half-life is closer to 13. My understanding.
I will send you a study which showed that while in the blood it is. Yeah, in the blood it is, in tissues it builds up, and even at very low doses you can actually get it at up to 2 days to basically stay there.
Wow, that is interesting though. So a lot more questions on methylene blue then. So one of the, we're going to go into other ways. I mean, you mentioned the quinines, CoQ10 and vitamin K2 and methylene blue, like quinine or quinone. But there's we'll talk about niacinamide and vitamin B2, because you want to stop those the reason the reductive stress is going is because the electrons are flowing backwards in the electron transport chain. Yeah. So, and many times that's due to reduced cofactors like NAD plus. But if those this is the question. If those cofactors aren't present, my understanding is that the beautiful thing about methylene blue, anything can block those complexes. Including cyanide or
nitric oxide.
Nitric oxide. It could block. Yeah, it's cytochrome 4. So whatever's blocking it doesn't matter, because methylene blue just transfers the electrons straight to oxygen, no matter what the heck's going wrong with those electron transport chains. So it would seem to me it's kind of like the ultimate solution for reductive stress.
Yep,
Am I confused on this?
No, you're absolutely correct. Even vitamin K or the simpler benzoquinone, of which coenzyme Q10 is a derivative, they can only work at specific steps of the electron transport chain. I think the CoQ10 is complex 2 and potentially complex 3. I think vitamin K is complex 2. However, complex 1 and complex 4, we don't know of any other quinone that can actually take care of them except methylene blue. So at any point, actually, even in the Krebs cycle, if there's a problem with the Krebs cycle, methylene blue can serve as an emergency oxidant. In other words, can accept these electrons. If you have a buildup of succinic acid and you don't have the necessary cofactor FAD, which is derived from vitamin B2, methylene blue to the rescue. We can actually go even there and accept those electrons and allow basically the electrons to continue floating through the electron transport chain. So yes, methylene blue is probably the most universal quinone that is non-toxic to humans, at least in the dosages that are used clinically, that can probably resolve most of the metabolic problems associated with a buildup of electrons or reductive stress.
So would it be fair to say that you believe it could be an important supplement for almost anyone?
Methylene blue in combination with niacinamide is probably the ultimate metabolic over-the-counter therapy you can do without taking thyroid or anything else that artificially increases it.
That is fantastic. Now, methylene blue is rapidly augmented and synergized with near-infrared radiation, which is 70% of the photons from the sun are near-infrared, or you can get a near-infrared sauna. But so ideally, you'd want to combine it with near-infrared.
Have you seen so several human studies are testing methylene blue for Alzheimer's disease.
I've not seen that. No, if you got more recent study on that, you could send it to me, great, because I'm interviewing Dale Bredesen real soon.
Yeah, 2 of them actually. There's a company in the UK that patented a slightly modified, really a salt of methylene blue. It's not a different molecule. It metabolizes into methylene blue in the body, but in order for them to patent it, they have to change the molecule somehow. Anyways, they created this methylene blue-like molecule, and they've been studying for Alzheimer's since I think 2011 or 12, and they found out in the most recent trial that it reverses the symptoms of Alzheimer's in 80% of the people.
Oh my gosh, that's crazy.
But there's a plateau. Yeah, there's a plateau of the benefits.
Wow, that is. Can you send me that?
Yeah. It's a remarkable study.
We're just doing like muscle testing and stuff to figure it out. But when you're sick, I think there's a massive benefit for taking a higher dose.
Higher dose and combined with red light, because then it creates the photodynamic effect, which is combination of red light and methylene blue creates singlet oxygen species, which is part of the reactive oxygen species, and those are extremely toxic to viruses and to bacteria. Pfizer has patented the photodynamic therapy with methylene blue and red light for cancer. And they're saying there's no need. Oh, yeah, I'll send you the patent. They're saying I think they patented like 10 years ago. They said, we've been giving people these toxic chemotherapy drugs and radiation. But really, the mechanism of action that we're after is we're increasing reactive oxygen species and killing the tumor cells because they're more vulnerable. They're saying, is there a way to do this in a less toxic way? Oh, look, methylene blue, red light. Combine the two, and they're saying this is our patent. And I'm surprised the patent was granted, but they said, look, we know about methylene blue and red light as killing pathogens, but we're patenting it for cancer. And of course, they created a slightly modified version of methylene blue, just like that UK company, and the patent was granted. Pfizer has a patent on using methylene blue and red light for treating cancer.
Wow. So do you think there's do you have any concerns for taking higher doses for people? Because it appears, especially for like long COVID, that there or any condition where you have this massive fatigue, which is obviously related to the metabolic rate, but as a short fix, of sort of a band-aid while you're addressing the other issues such as the macronutrient ratios and revising the diet, that higher dose of methylene blue would be useful for energy.
I think the ideal thing is to combine it with niacinamide and keep the dosage at about 15
of course.
to 18
we haven't talked about this. It's on our list, but man, that niacinamide is a no-brainer and it's almost free.
Methylene blue is a relatively strong monoamine oxidase type A inhibitor, and in combination, which means it's going to decrease the degradation of serotonin, which means it's going to increase the buildup of serotonin. So if you're taking anything that contributes to the serotonergic tone, it's potentially dangerous. Multiple case studies published of people going to the hospital in shock, and methylene blue is the preferred treatment for shock because it rapidly recovers the blood pressure and the perfusion of the tissues, which are dying because there's no blood supply. But they noticed that since they give a very high dose of between 100 and 400 milligrams as a single injection, they had cases where people went into a serotonin syndrome because they didn't know, because when somebody comes in critical through the door, you don't always know what medication they're taking, right? Then people went into serotonin syndrome, and there's a known interaction of methylene blue with SSRI drugs. And if you go to like even CVS or like Rite Aid Pharmacy and tell them, hey, what medication should I not take together with methylene blue? The first thing they'll say is SSRIs. I've already tried at the local pharmacy.
Yeah. But I've interviewed Francisco Gonzalez Lima, who's supposedly the top methylene blue researcher in the United States. It's at the University of Texas. And I had this question. I asked him the dosing. They have the researchers. I don't know if you realize this. They have not studied doses below 0.5 milligrams per kilogram.
Really?
Yeah. I said, well, what about lower doses? It makes more. Why not lower? We don't know. We haven't studied it. Which was shocking to me. But that 0.5, that would be so it's
like 40-50 milligrams for most people.
Yeah. So but I was doing like 15. I said, I think it's like 0.115 or maybe even 0.2, not 0.5.
Two great studies that I'll send you. One of them remarkable. You can send it to him. I'm surprised he doesn't know about it. Methylene trials for clinically for suicidal depression, impermeable to any treatment, and another one for psychosis. So the psychosis trial is really interesting. So they had several groups. One of them, they gave methylene blue at a very high dose, 300 milligrams daily, and they said, this is the active group. But because people who are taking methylene blue, they know they're taking methylene blue. So in order to properly blind them, we're going to have a placebo group, which also gets methylene blue, but only at the 15 milligram. And guess who had the biggest benefit? The placebo group.
It would have to be in serendipity research, trial. Yeah. It wasn't by design.
Jeez. I mean, it's just the 300 milligrams had some improvement, but not statistically significant. Placebo got worse, and the 50 milligram group got their psychosis cured. And then another study, because I think probably by the same researchers who said, okay, 50 milligrams methylene, there must be some magic to it. Let's try it for depression. In 2 weeks, 15 milligrams of methylene blue got rid of treatment-resistant depression.
Oh my gosh! So, Georgie, I've listened to many dozens, probably coming up on 100 of your podcasts now, and I've heard you talk about methylene blue, but I've never heard you strongly endorse and recommend it like you do niacinamide. Well, why is that? Why aren't you talking about it more?
It's just that a lot of people. I'm concerned because, like you said, 40% of women of childbearing age are taking SSRI drugs. Many men are as well. I don't want to sound too because it can be if you're taking a lot of SSRIs, and a lot of people taking the high dose too. I know a lot of people who are only on SSRI drugs and are already showing up jittery and confused, which is like a precursor to the serotonin syndrome. These are symptoms of that. Very, very little. They need a very extra little help to get into the serotonin syndrome, which, by the way, has 30 to 40% mortality rate. Definitely not something I want to be involved with. Okay. So I love it as a molecule if you know how to play with it and use it wisely. Unlike vitamin K, which can abuse as much as you want, and it has no known side effects. But of course, at the expense that it's much more selective, while methylene blue, being the proverbial power drill, right, can resolve all of your problems, but you have to be careful with it.
Wow. Was not expecting this. This is fantastic. So, man, this is great. So that's one thing I wanted to mention that Gonzalez Lima Peru mentioned to me is that it's pretty much everyone should have it in their emergency cabinet. Now, you don't have to take it, especially if you're concerned about the serotonin syndrome. But if you get a stroke or a heart attack, you are out of your mind. It is the first thing you should reach for and swallow, 100%. And what would assuming that you're not on SSRI, what would you, if someone had a stroke, what would do?
Even a single milligram will do great. There's multiple animal trials, which if you translate the dosage, comes down to less than 50 milligrams single dose. Even any dose over a milligram and less than 50 milligrams will do just fine. There was an in vitro study which showed full reversal of aging in human cells. Unfortunately, it wasn't in vivo. And that study showed that the optimal concentration for anti-aging benefits, which means for longer-term consumption, is about 100 nanomoles per liter. In most humans, of course, it depends the volume of the human, right? Some people are bigger than others. But in most people, you can achieve that with daily doses between 5 and 15 milligrams daily. So really, for me, the combination of all of these studies, the treatment-resistant depression, the psychosis, the Alzheimer trial, which found plateau at 80 milligrams, actually 60 milligrams, kind of tells me that the optimal dose is somewhere between 5 and 15, depending on the person. But any dose, even in the microgram amounts, if person has a stroke or any kind of other acute event, any amount, any that can get into your bloodstream is probably going to be helpful.
All right. So I was recommending a bit higher dose, but still significantly lower than the experts were recommending. I knew it wasn't 0.5 milligrams.
And
that was their low dose. That was their low dose. They go up to 4 milligrams per kilogram.
Yeah, because that's the clinically used dosage in hospitals. If you go in the hospital in a shock, the dosage is by injection for 100 to 400 milligrams bolus, meaning a single dose. Yeah.
Yeah. And the other thing too is that there's a lot of natural medicine clinicians who get methylene blue and they use it, but they use it in an IV, and it's ridiculous. There's no reason to use it IV. The absorption orally is close to 100%, isn't it?
Yep, but it's there's no difference. In fact, I've seen several animal studies that show that the bioavailability was a little bit delayed, but the total bioavailability is close to 100%. So there's no reason to do IV.
So if you're dying from cyanide poisoning, go shoot an IV. But most people aren't dying of cyanide poisoning, where every second counts. I mean, they can wait a few minutes and get 100%.
Carbon monoxide poisoning, also methylene blue is an antidote to that. It's very dangerous.
Yeah, I mean, people die from it all the time, but if you
it doesn't smell, you won't even feel it. You just collapse basically. Or initially, if you lightheaded it, but if you start doing that, methylene blue immediately, because that's probably the quickest antidote to almost any metabolic problem.
Okay, well, this was I knew there would be a lot of unexpected bonuses, and this was a huge one. I mean, this is a radical game changer. So thanks for that insight. Because I was just like, listen, when is he going to start talking about methylene blue? I didn't realize he was just concerned about the serotonin syndrome. On a podcast that I listened to actually this morning, you were talking about the value of Listerine in changing the oral microflora to have some really powerfully beneficial effects. Of course, Listerine we're not recommending that because it's toxic as can be, but you're recommending a safer alternative that just happened to be a dilution of methylene blue, maybe this magical 10 or 15 milligrams that you talked about, putting into a liter of clean water and using it as an oral rinse. And you had also suggested adding some ethanol to increase it, which you suggested putting in a quart of vodka.
Quart of vodka, and you're going to be mimicking the Listerine without the side effects. Because some of the antiseptic effect of Listerine is it's kind of like it's because of the alcohol. Look at the contents of the label. I think it says 40% or 20% alcohol on the Listerine bottle.
It's not ethyl alcohol. What is it? Ethyl alcohol?
It could be isopropyl, maybe.
I thought it's probably isopropyl, which is not good.
It's not good. You don't want to ingest it. No, don't want to.
I mean, I wouldn't even let someone put isopropyl alcohol on my skin with those alcohol wipe pads, I just use peroxide. Yeah. So, so I guess, so you like that better. You think the ethanol would really help the methylene? I was curious because methylene blue is absorbed so well into the tissues. Why would you need ethanol to push it?
You
through?
won't. I think it was commenting on how can you mimic Listerine at home with a naturally made formula. But you can get by simply by doing the methylene blue at the same concentrations that they use for sterilizing aquariums and for killing all the fungi and the viruses and the bacteria for the exact same reason. Think of the aquarium as your mouth. So the exact same concentration. I think it's 5 to 6 milligrams per liter. So at that, the water will become very kind of vibrantly blue color, but I don't think it's going to change the coloration of your mouth.
Yeah, the only thing I would be concerned about, and just caution having partials myself or even full dentures if you had them, but I would take those partials or dentures out of your mouth because those will stain. But your teeth don't. I'm going to stain a little bit, but not permanently. It disappears because as soon as it's reduced, it's
the body uses it. In fact, on the forum long time ago, we proposed the methylene blue test of health. What is the oral dosage of methylene blue that you can take before your pee starts turning blue? And the lower the dosage at which you start peeing blue, the healthier you are.
Yeah, the problem with that is that if you're taking riboflavin,
that can change things.
It's going to be green.
Green or whatever. Yes. So pure, no other supplements, only methylene blue. And if you can get you pee blue at like 5 milligrams, that's good. The higher the amount that requires, another way you can do the skin test, but it's mostly a localized test of health. In fact, they're using it for cancer biopsy for that reason. When they're looking with a camera and a scope, like somewhere in your internals, and they see a problematic area, they go and inject methylene blue, and then basically they measure how quickly the methylene blue gets this color. They have a threshold. If it gets this color, quicker than, 30, I'm making up a number. But if it's quicker than a certain number, they're saying this tissue is cancerous. And then they're going to take a biopsy.
Wow. Yeah. That's pretty good. So I'm Most of the people I see, it's like 30 to 40 milligrams before they start peeing blue. So that's relatively high, I guess. I mean, what's the lowest you've seen where 5 milligrams?
Very young people, yeah. I mean, basically like people in their teens.
Wow, that's good to know. That's good to know. Which is consistent with your recommendation of such a small dose. It's 10, 15 milligrams or so.
Yeah.
Wow.
And because the cancer reduces the methylene blue so quickly, it shows you that extreme reduction is definitely bad, right? Cancer is by definition in a reduced state because it's consuming the oxidized methylene blue at such a rate. Diabetes, a state of extreme reduction, and then oxidative stress, a state of another, but less extreme. So just a continuous spectrum from health to cancer. It's just measured by the degree of reduction in the organism.
That is an unbelievably beautiful anecdotal confirmation of reductive stress theory. It really isn't a theory because you've got the data to support it, but supposition. It's beautiful. I mean, this has got to be adopted and understood and applied because it's so powerful. Once you understand it, it just helps you navigate the whole process much easier.
I think the only hurdle currently is not that the medicine doesn't know about these things. They're convinced that the structural damages in most diseases come first, and there always some genetic vulnerability, susceptibility. They still can't get over the fact that a simple metabolic disturbance, if propagated over time for a significantly long period of time, will cause those structural changes, and then it will become a self-propagating cycle. So first you have the metabolic disturbance or the functional problem. Over time, it leads to a structural problem. But in the structural problem, now you have deranged tissue, which contributes to even more functional problem. And on it goes until something breaks that vicious cycle. You want to hear other benefits of methylene blue? Yeah. It's a very powerful aromatase inhibitor at an effective concentration of about 500 nanomoles. Yeah, so it's a sub micromolar concentration effective aromatase inhibitor.
Wow. Did not know that. That's great. So I guess we're going to talk about niacinamide in a moment too. But anyway, we'll go to obesity treatment. Obviously, the whole world is pretty much suffering with it. We're talking about more than 80% of the people have struggle with their weight. And I think the latest estimate is about 95% are metabolically inflexible, which goes to the point of not being metabolically efficient, which is exactly what we're talking about. So what are your best strategies for addressing the obesity problem, especially in those who are resistant, really struggle with it? And, I want to get into the RAU46 and some of the other strategies that the novel approaches that you've mentioned in the past.
So dietarily first, I think we both agree on that 100%. Absolute avoidance of PUFA as much as possible without going orthorexic. Okay, you shouldn't be killing yourself. I mean, it's not possible practically to completely avoid PUFA into the dietary.
I got my level down to 1%.
Wow.
1%, not PUFA, but just omega-6.
Just omega-6. Okay. Yeah. So yes, avoidance as much as possible. And also maybe a little bit of coconut oil, maybe like a tablespoon with each meal, because it's not only the absolute amount of PUFA, it's also the ratio of saturated fats to PUFA, which determines both the metabolic rate, which the coconut oil raises, and also the reduction of oxidative stress, which is, reductive stress really. PUFA raises that, while coconut oil has been shown to reduce it.
But if you're taking ghee, would you need the coconut oil?
No. So I mean, I'm mentioning coconut oil because it's you can carry it around with yourself, and most people are okay with refined coconut oil because it has no taste. Even ghee, which I love the taste of, most people kind of bulk it like, I don't want to eat a spoon of butter. But if you're cooking with ghee, then you probably don't need the coconut oil to start with.
And one of the best foods out there is those boiled potatoes with ghee and a really good sea salt. Oh,
Yep. And some cheese. You can put some Parmigiano Reggiano or Pecorino Romano. Man, the best. Yeah. Okay. The Russians, the Soviets actually did the study after Second World War about they call it the potato diet. You can not only survive, you can thrive on a diet of nothing but butter and potatoes and salt and water. That's it.
Yes, because it's got the keto acids for the protein, right?
Everything, exactly. Everything in there. It's got potassium, but even higher than oranges. It's got magnesium. It's got all the cofactors. It's got all the vitamins that you need as well. So you can thrive on a diet of potato and butter. I don't know of any other...
Just make sure it's well cooked.
Yes. Yeah, of course. But if you're in a state of war,
it's a good
eat even raw.
And one of the things I had recommended earlier. I didn't realize it was spot on because at the time I was carb phobic, but I told people from their preparations of when COVID was going on, the food was shortages were impending, to pick up some 20-pound bags of rice, white rice. I mean, it's crazy not to have that. I mean, you can survive on that food. I mean, obviously it's depleted of nutrients, but it will give you helpful calories that aren't going to wreck you up metabolically.
White sugar, packed sugar, like a bag of white rice, bags of white rice. Condensed milk is also probably a pretty good thing to have. It's usually sweetened, but it doesn't have to be. I mean, even the non-sweetened version is pretty good. So yeah, these are things. Canned fish, canned food, canned oysters. Also pretty good.
The problem with the canned foods, though, is you've got the liners,
the endocrine disruptors,
endocrine disruptors in there. But, I mean, if you're doing these other things like methylene blue, probably messes with those too. So
you can block most of methylene blue. Another very interesting study. A study showed that you can oxidatively destroy most of the endocrine disruptors by either keeping your metabolic rate high or taking oxidizing agents such as methylene blue. Isn't that great? You can actually block most of the endocrine disruptors from bothering us simply by taking methylene blue daily.
Who would have known? And the experts, I mean, there's some really good, committed individuals out there where there's life work is in warning and informing people about these endocrine disruptors, but no one is talking about using methylene blue as an antidote because sometimes they're just unavoidable. They're pervasive in our environment. You touch the receipt on your grocery store thing and you're getting
the highest amount of BPA than any other thing in your environment.
Yeah. So, it's almost unavoidable unless you're living in a bubble. So we need these types of solutions. So, one of the things you had mentioned in my first podcast with you is DNP, and you mentioned earlier on this one too, the dinitrophenol is a mitochondrial uncoupler, which simply means that instead of your electrons flowing through electron transport chain and generating ATP at cytochrome 5, they're shuttling outwards and creating heat.
Exactly. Yeah.
So it raises your metabolic rate quite a bit. And DNP, dinitrophenol, is actually illegal in the United States because it killed a lot of people. But it wasn't illegal because it wasn't effective. It worked. But
by raising their thermogenesis too much, and they died of heat stroke. That really was the key. But you go to Mexico, you go to Thailand, you go to any other medical tourism places, and you say, I want to lose weight, DNP is one of the first things they'll offer.
So the other metabolic uncoupler is aspirin, which, is another, there's a few things that I think seem to be universal. Methylene blue would qualify if it was for serotonin syndrome, but the aspirin, niacinamide for sure, probably vitamin E, maybe even glycine. These are something almost everyone benefits from. And in some ways, it really should be considered a supplement or drug because it's so essential to our optimizing survival in this type of 21st century environment. So do you'd mentioned the first time that they were doing, you saw studies where they're doing 9 grams, which is literally 27 full dose aspirin a day, which is probably caused tinnitus or tinnitus, and most of the people took it. But it was a very effective uncoupler and people lost weight with it. So are there other strategies like that you'd recommend? I think 9 grams of asprin is a little bit too extreme and it might cause problems to a lot of people.
Caffeine? Also metabolic uncoupler, very old study. Yeah. In 2014, when I first joined that infamous Rapid forum, one of the first studies I posted there because I found and I thought it was interesting is that caffeine, depending on how high of a concentration you do, works the exact same way as dinitrophenol. It's widely acknowledged that caffeine raises your basal metabolic rate, but most of the dosages that are used are within the 50 to 100 milligrams per study, right? And that even that low dosage raises your basal metabolic rate by 4 to 5%, and this increase stays for about 12 hours. So just 2 coffees a day will be raising your basal metabolic rate by couple of percentage points, and that effect will probably stay throughout the entire 24-hour period until you start drinking the coffee again. But at higher doses, but still lower than the aspirin. So the equivalent of human dose of about 1 gram a day, which is kind of on the high side, but I know people who are consuming it. At about 1 gram a day, caffeine had almost the exact same uncoupling effect as dinitrophenol. And multiple animal studies actually compared them head to head, the exact same weight loss achieved by the caffeine as the dinitrophenol.
Wow. The only thing at that dose, of course, is you want to be really, really careful about taking it too late, especially if you're caffeine sensitive and you don't metabolize it well.
Also, caffeine inhibits your synthesis of urea from ammonia, so you can actually get a buildup of ammonia, especially if you're on a high protein diet. So you want to be careful with caffeine, but not as dangerous as DMP. And of course, it's widely available, so you don't have to break the law to get it.
So if people aren't drinking coffee, could they take a caffeine tablet?
Sure, caffeine tablet is great, and if you get the jitters of it, usually it means like you don't have enough glycogen stored in the liver, because the way the body processes the caffeine, and because it also raises the metabolic rate, it says, let me throw more food at it. So caffeine is like the spark, it's the catalyst, right? But if without the fuel, you'll be running on empty. So make sure you take it with a sufficient amount of fuel. And if it still gives you the jitters, usually combining it with glycine, which is an inhibitory amino acid, or theanine, which is more popular now. In fact, there are even products on the market combining the theanine amino acid found mostly in tea with caffeine, because it completely eliminates that unpleasant stimulating effect of caffeine.
What about adding theanine with GABA too?
Fine. Taurine is another GABA agonist, another inhibitory amino acid. Unsurprisingly, taurine is in Red Bull precisely for that reason. They found out exactly how much taurine you need to block the jittery effects of a specific amount of caffeine.
How much is it typically? A few hundred milligrams?
I think it's like a 1 gram per can. So a 1 gram per can neutralizes
per can.
Yeah, a gram of taurine per can. Yeah.
Wow.
Yeah. But I think it's there also for another reason. They consume a lot of monosodium glutamate in East Asian countries, and taurine, the formula, was originally invented in Thailand. So taurine is a known antidote to monosodium glutamate, because glutamate is an excitotoxic amino acid. So they eat a lot of monosodium glutamate because it's got this. It's a flavor enhancant that they add to many like soy products and different meats. So the way you prevent the jitteriness and the excitotoxicity is you eat inhibitory amino acids, either taurine or glycine, right, or theanine, which is in tea. So taurine was this formula, the Red Bull formula, was invented to kind of like offset some of the damage that the monosodium glutamate does. So the dosage is a little bit high. I think 1 can of Red Bull has about 80 milligrams of caffeine. For that, it may be about 250 milligrams of taurine is enough to negate the jitteriness. The extra taurine on top of that, I think, is because the drink was meant to combat monosodium glutamate toxicity.
Yeah, but glycine would be helpful too?
Perfectly fine. Glycine, taurine, and theanine are all GABA agonists. So even though they basically act like GABA, or you can take GABA if you want.
Yeah. So because there's some other, I think we're coming up with a supplement that's GABA and theanine.
Yeah. Beta-alanine, also GABA agonist. And for a long time, medicine was saying, very good.
The precursor for
carnosine.
Which is most people don't know, but you would. Ages are terrible, but ALEs are even worse. And carnosine is a really effective sacrificial sink for it. It just binds to it, so before it hurts you.
Yep. And the medicine for a long time has claimed that oral GABA is not bioavailable and it doesn't cross the blood-brain barrier. Recently, all of this has been falsified. I mean, debunked, just as we're debunking the oxidative stress and cortisol being an anti-inflammatory. I don't know if you want to go into that next.
Oh yeah. Well, let's finish up with the obesity thing.
Okay.
So, and we'll talk about proteins too. For resistant obesity, you gave us some ideas of the uncouplers, but clearly cortisol is the primary contributor, and you get to this vicious cycle, right? The cortisol makes it worse, and you get heavier, and that increases weight, increases the cortisol. So you talked about RU46 or mifepristone as the abortion pill, as it was initially developed as a cortisol blocker, and then subsequently found to also block progesterone, so that it could be used as an abortion pill. But the primary purpose was to block cortisol. So does it block anything else other than progesterone? Like, does it block testosterone? Because we had talked earlier at the beginning how the anabolic steroids are actually useful because they're anti-cortisol, and it's limiting the cortisol impact on your catabolism is their primary mechanism of action. So could you use RU46 in treatment of obesity, assuming you supplement with pregnenolone or progesterone to counteract the impact on those receptors, or is it just not a wise idea?
I don't know if it's a wise idea, but would it be effective? Absolutely. There are multiple. If you go to the bodybuilding forums, that's actually one of the accepted ways to lose weight without dieting.
Really?
DMP or RU486, or upping your dosage of testosterone, whatever anabolic hormone you're taking, because you will block cortisol that much more, right? And then basically you will, you'll lose the weight. So if you're a competitive bodybuilder, they're saying you're already taking the anti-cortisol hormones. You don't need to take any more. But if you're kind of like into the healthy bodybuilding stance, you don't want to become a huge Hulk. They're saying, look, if you just want to keep the weight off and be shredded and have decent muscle mass and not have a big belly, just take RU486. It's basically less risky than the anabolic steroids.
But you would want to take it with at least pregnenolone, right?
Definitely, yeah. Because any other steroid, it's probably going to disrupt one or more of the steps of the downstream cascade. And usually, even for the anabolic steroids, there's the infamous roid rage. And they found out that the reason the roid rage occurs is that most anabolic steroids block the synthesis of progesterone as subsequently of a metabolite of progesterone known as allopregnanolone, which has a very potent calming and antidepressant effect. FDA recently approved allopregnanolone as a rapidly acting antidepressant. So clearly, if you're interfering with its production, you expect people to get either depressed or angry, which is a very common sign of depression as well. So these anabolic steroids were disrupting one or more of these steps. So taking pregnenolone or progesterone was found in animal studies to prevent the aggression associated with anabolic steroids. So RU486, also a steroidal molecule, likely to disrupt probably the initial steps of the steroidogenesis. So yes, pregnenolone or progesterone and DHA. But I think pregnenolone is probably the easiest thing, just one thing for people to remember to take.
Yeah,
together with the RU486.
When you take oral pregnenolone with the with the fat, a saturated fat, more than 14 carbons, which you mentioned in our first podcast, does it convert to allopregnanolone?
Basically, so what you want is as much of the pregnenolone to get absorbed through the lymphatic system, right, to avoid the first pass metabolism to the liver. And once it gets released into your bloodstream through the thoracic duct, then basically it gets converted into whatever the body needs. High doses of oral pregnenolone in humans, multiple clinical studies with schizophrenia and other mental disorders show that high doses of oral pregnenolone in humans raise predominantly three hormones, of course, pregnenolone, right? DHEA, because pregnenolone is a precursor, and allopregnanolone. So these are the preferred pathways for converting pregnenolone into. And of course, further down, androgens and estrogens and corticoids is needed, but it turns out that the precursor mostly goes into these beneficial pathways that we know about, allopregnanolone being one of them.
So in my view, I consider for almost all adults, a daily pregnenolone DHEA supplement would be a really good idea, because they're so helpful for combating excessive estrogen, which is like pervasive and almost a factor in almost all chronic diseases is excess estrogen.
Oh yeah, I mean, estrogen is probably the primary de-differentiating hormone we have. Unsurprisingly, it increases the oxidation of fat. It decreases the oxidation of glucose. It increases the synthesis of cortisol. In other words, activates the stress response, because that's what estrogen is. Many people think of it as a female hormone. No, men can produce as much as females do. And in fact, older males, basically, if you look at menopausal females and older males can produce much more than females do. And I don't know if you've noticed that the very old people phenotype, the males get kind of feminized, and the females get masculinized. They really kind of merge into like a unisex kind of looking organism. And it's now known that estrogen is one of the primary determinants of that. Excess estrogen feminizes males and masculinizes females.
All right, well, let's get back to, we started in niacinamide, but we kind of escaped it. And in our view, both of our views, you are almost out of your mind and irrational if you're not taking niacinamide. It's almost free. Like it's a few dollars a year if you buy the powder. You only need like 50 milligrams a few times a day. I'm even up to 4 times a day. I try to take mine in equal spaces. Like 50 milligrams of a powder is 1/64 of a teaspoon. Pretty easy to do, and it has no taste at all. It's just you could even swallow it directly, but it's so much easier to put it in water. So and we talked about the PDH, the pyruvate dehydrogenase, is the throttle that for the Randall switch. But what activates that PDH, the pyruvate dehydrogenase, is niacinamide, or actually the conversion to NAD that activates it. Yeah.
So if we have an excess of NADH and deficiency of NAD, causing all of these metabolic problems, whether it's reactive to reactive oxygen species, oxidative/reductive stress, or actually if you have too high of an NADH to NAD, you won't even be synthesizing a sufficient amount of ATP. If you look at the studies, they show that ATP levels have an almost perfect correlation with NAD+. So the higher your NAD+, the higher the ATP synthesis is, and the better your metabolism works.
That's huge. That's a pearl that, like, I didn't even realize that. I'm a huge niacinamide fan, NAD+. I never knew that there's a direct correlation between ATP and NAD.
80% of your ATP production comes from NAD+, the other 20 from FAD.
Now, and you need the magnesium too, right? Because it's always magnesium ATP.
Because if you take magnesium, so here's why a lot of people that are taking magnesium may not be feeling the benefit of it, is because they don't have enough ATP synthesized. If you don't have enough ATP synthesized, the magnesium cannot bind to the ATP, and it's in the body. It's always bound to the ATP as a complex. So magnesium will be floating around in its free ionic form and very quickly excreted as well. So which means that people who are the most needy of magnesium are the ones who are least capable of absorbing it and making use of it, which means that if you be taking magnesium, make sure you take it with some niacinamide, because niacinamide will raise the NAD, which will raise the ATP, and then you'll be able to utilize the magnesium instead of just giving you loose stools or intestinal irritation.
Do you think the timing of those should be similar, like taking the niacinamide with the magnesium?
I think first niacinamide to give it some time to raise the NAD. It takes about half an hour, and then you can take the magnesium a little bit later.
Okay, and then because it's a B vitamin, it has a very relatively short half-life, in a matter of hours. So you'd want to take it multiple times a day. You just don't take one dose for the day, and that's it, right?
Exactly. Yeah. So the smaller doses, because the NAMTP enzyme, which synthesizes NAD, is easily saturated. So if you take too high of a dose, you're going to block that enzyme, and in fact, most of that niacinamide dose will float around and get converted to something called 6-methylnicotinamide, which is a metabolite. Helps the body excrete excess niacinamide, nicotinamide, right? But again, you'll be mostly wasting it. Now, some studies have showed some interesting beneficial properties of even 6-methylnicotinamide being an anti-inflammatory, anti-estrogenic, basically a lifespan extending substance, but it's not as beneficial as letting niacinamide get converted to NAD+. So you have to take a dosage that does not block the NAMPT enzyme, and that dosage in humans seems to be, for most people, less than 100 milligrams per pop. Which means 50, as you said, right? So 50 milligrams several times daily, you're going to be converting mostly into NAD without creating any excess that can block any of the other pathways.
Beautiful things. And you talked about the 6-methylnicotinamide. You probably know this, but it took me a long time to figure this out when I was studying NAD, that nicotinamide and niacinamide are two different names for the same damn molecule.
Exactly.
Yeah. So most people don't know that. They hear it's, what is nicotinamide? They actually decide that's the scientific term. And then they realize, most lay people confuse it with nicotine. So they decided to make it less onerous and name it niacinamide, which is, that's why I like to use niacinamide, just decreases the confusion. But one of the other things that made me nervous about taking high doses of niacinamide, because when I was studying it, the literature was really clear. High doses, they never specified what a high dose was, but high doses has negative impact on the sirtuins. And lo and behold, I read one of your blog posts. The whole thing was upside down. The sirtuins are not as helpful as with the longevity protein.
You don't want to mess with them too much. Yes, like autophagy, right? It's there for a reason. You may modulate it a little bit, but too much. It's a mechanism that sirtuins, just like autophagy, is implicated in promoting already established cancers. They can prevent the cancers to start with if you're activating them. But once already tumor is present, you probably don't want to be messing with the sirtuins.
Yeah, it's interesting. David Sinclair is the scientist who catalyzed my interest in NAD in about 2014, 2015. He had some very compelling research. And of course, he's the guy responsible for maybe doing the initial research on resveratrol, which you're not a big fan of, for sure.
No. Yeah, they actually a functional antagonist, resveratrol and niacinamide. So if you like one, you probably don't like the other.
Yeah. So, and he does not talk a lick about niacinamide. Never does. He talks about NMN, or as a derivative of one of his companies, I think Metro or something, put out. Actually, it was his research, his company's research that did the work on this NMN that got NMN off the market. I don't know if you know, it was Sinclair.
Oh, yeah, FDA said no longer sold over the counter because it's a new drug, a novel drug, or whatever they call it.
Yeah, because I think it was Metro Pharmaceuticals. It was Sinclair's company.
Yeah, in Boston. I just sold it in Boston. It's his company? I didn't know it's his company.
Yeah, it is. Yeah, it is definitely his company. Or is he's connected with it in some way? I don't know if he owns it, but he's definitely connected. But anyway, the reason I was sharing that story is that I thank him for waking up my interest to this, because we've known about NAD plus since 1905, I think. It's been over a century. It's because it's an essential part of the Krebs cycle. And so I was fascinated about it because of its impact on the sirtuins and PARP and CD38. But then after studying your work and Ray's, I realized, damn, it's still all about the basics, the Krebs cycle. That's why it really works, is because it's ramping up the ATP production. It has nothing to do with the sirtuins.
Yeah. It improves your metabolic rate, no buildup of electrons, or at least tolerable buildup of electrons, no reactive oxygen species, and then basically you stay healthy for longer.
And this is another mind-blowing pearl that I don't hear you mention it, but I did hear it on one podcast. It actually is the required cofactor to take cortisol, which we've talked all about as dangers, and convert it to the inactive form of cortisone.
And also to take the active form of estrogen called estradiol and convert it into the less active form, still active but less dangerous, called estrone. So estradiol fully reduced.
Oh.
Yeah.
Dang, another good thing. So you just got to be irrationally out of your mind if you're not taking niacinamide. There's just simply no reason not to. None. Zero. Nada.
Mm-hmm. Yep. I take it every day.
Yeah, and actually, I could announce here, because as we're shooting this, we're about 6 weeks out from actually producing what I believe is the only 50 milligram niacinamide tablet on the market. So
the only one. I've searched for a long time.
Yeah. So I realized for a long time, because I've been taking niacinamide at that dose for a few years now, but it takes us a long time to make these supplements. It's just a lot of, well, you have a supplement company, so you're
legalese and trying to
and just raw materials and labeling and getting all that stuff out. But the other thing is how common would you say liver disease, like NAFLD and then the alcoholic fatty liver disease too? I've heard you say 70-80%, and the reason I mentioned that because it's helpful for this too.
Yep. So, some form of liver disease. So you have NAFLD, right? Then you have the more severe form, which is NASH, non-alcoholic steatohepatitis. Then you get basically the fibrotic states such as cirrhosis, and ultimately liver cancer, which is kind of like the final progression. Then you have the fattening liver from alcohol, and I don't know why they're separating non-alcoholic fatty liver disease from alcoholic fatty liver disease, considering that they basically cause the exact same condition.
Yeah, identical. There's no difference.
But if you take in niacinamide, basically you're preventing, by improving the metabolic rate, you're preventing a lot of the buildup of these reactive oxygen species, which are attacking the polyunsaturated fats that are in the liver. And it's been shown that it's this peroxidative process that is responsible for most of the damage that occurs in the liver. The other portion is increased lipolysis, which supplies those fats to the liver. And guess what? Niacinamide, by converting it to NAD, restrains excessive lipolysis. I emphasize excessive. It does not inhibit baseline lipolysis. Insulin does, but not niacinamide, not NAD. If you're too much lipolytic, it will lower them. And I think, I don't know if you sent you the article where single low-dose niacinamide, I think it was 100 milligrams, dropped triglyceride levels by 75% in humans. So that means it's rapidly, because most of the triglycerides are coming from the fat, right? Either you ingested, but these people were fasted. So which means most of the fatty acids were coming from the fatty tissue. And if you're decreasing the triglycerides by that amount, which means you're probably inhibiting lipolysis by about 75%.
Does the aspirin... I know aspirin inhibits lipolysis too, but does it inhibit baseline lipolysis?
That I don't know if it's been studied. It's possible because it's known that aspirin in very large doses starts to mimic insulin. And that's one of the reasons why they're using it back in the day when they didn't have insulin isolated. If somebody shows up in the hospital with diabetic ketoacidosis, one of the treatments they had was very high dose intravenous infusions of sodium salicylate, which is just the analog of aspirin. So they were using it in lieu of insulin. And since insulin can suppress baseline lipolysis, chances are that very, very high doses, not something that I would try, and by the way, it was by IV, it wasn't oral. So I think they were giving the equivalent of the 9 grams that we discussed over a period of a few hours through IV, and that was acting like insulin. But in the regular doses, I think the one that we're discussing here, no more than a couple of grams daily or just a few tablets daily, I think it's still related to excessive lipolysis. You don't want to inhibit baseline lipolysis too much because you remember at rest, your muscles rely on it. Yeah, so you don't want to starve the muscles.
And what's the primary fuel source for the heart? Is it fatty acids?
At rest, but then once you start exerting yourself, it's because the beta oxidation process is too slow to basically meet the requirements. When you're exerting yourself, the heart starts to demand glucose, and one of the most successful ergogenic products on the market is the drug mildronate. This light. And the meldonium, the way meldonium works is restricts the oxidation of fat and allows the heart to use more glucose. So, but it only works as an ergogenic aid when you actually need it. If you're at rest and you take meldonium, it's not going to give you more energy. But if you're running, let's say if you're running a marathon or you're doing a tennis match, unsurprisingly, tennis players used to abuse meldonium before it got banned by the World Anti-Doping Association, WADA. Tennis player Maria Sharapova, meldonium being a former Soviet drug, was using it. And basically, when you're under exertion, it increases your threshold to failure, so to speak, by about 30 to 40%, which is huge. So if you're playing a several-hour-long tennis match, right, being 40% more resilient or quicker or more energetic, of course, can mean a difference between winning and losing.
Okay, great. This is phenomenal stuff. So I want to progress to the hormone of darkness, supposedly, which is melatonin. It's a bit intriguing because it's gotten a lot of publicity and it seems to be really good. But here's an interesting thing. It's an antioxidant and, foundationally, it could contribute to the reductive stress that we talked about earlier.
Absolutely.
So yes, independent of its role in augmenting sleep, because there's two roles. One, actually, it's connected because it's pineal gland secretes it at night when you're in darkness, if you had bright light exposure in the daytime, and you didn't see blue light before you went to bed, then you're going to get it. But still, that's only 5% of the melatonin your body secretes. 95% of it is made in the mitochondria, subcellular mitochondria, or subcellular melatonin, and in response to near infrared light, which is just an amazing, powerful nutrient. I think it should be a nutrient. There's like we talk about all these supplements and nutrients, but sunshine has got to be part of it. There's just no way around it. And, I look at the vitamin D level as a biomarker, assuming that you're not swallowing vitamin D, it's a biomarker for sun exposure.
And for longevity and for many other things, the most reliable predictor of future development of something like multiple sclerosis is for how long you were vitamin D deficient. There's an almost perfect inverse correlation. Inverse correlation between latitude and basically and rates of multiple sclerosis, with the rates being the highest in the Scandinavian countries and going down to virtually zero around the equator.
Yeah, but that's correlation. It's not causation, of course. Right. And I think the correlation is there because it's sun exposure.
Sunlight, yes.
I don't think you're going to get the same benefits, autoimmune benefits, if you're swallowing. You may get something similar, and a lot of the vitamin D researchers believe that. I suspect there's some truth to it, but it's going to be far in excess if you get it from the sun. I haven't swallowed vitamin D in over 15 years. And I just had my blood test back from vitamin D last week. It was 99 nanomoles per liter. But
you live in Florida, right?
I live in Florida, and I am obsessive about getting out at solar noon every day to get into the sunshine. It is absolutely crucial from my perspective. You got to have that. Don't have to, but it really, because you're getting 70% of the solar radiation is ultra or near infrared. Did you know that? 70%.
Yeah. Some people said, it's been known in the the industry that produces electricity from the sun. They're saying, like, look, if we're only using the photons to produce the electricity, we're actually wasting most of the sun's energy because it's mostly in the infrared spectrum. So we're going to get more energy by trying to heat things up with the sun instead of converting the photons into electric energy. So most of it that we get is heat and the invisible infrared spectrum.
Yeah. Yeah. Well, the near infrared doesn't heat as much as the far infrared does. So I think most of it's in the near. So definitely you can get. I had one. I actually still do in my house. I have a solar water heater, and so I don't use an electric heater to heat the water. I use that, but I don't know if it's efficient. That's the issue. But anyway, it's a tangent. So I'm wondering what your the thoughts are on melatonin, because for those who aren't familiar with melatonin metabolism, we talked about the negative impacts of tryptophan. It's like not a good amino acid that you want to have large amounts of. But tryptophan gets converted to 5-hydroxytryptophan, which is also called serotonin. And serotonin is a direct precursor for melatonin. So I don't think anyone's in disagreement that we need melatonin. That there's no dispute there. But the concern, and it's sort of the confounding variable, the difficult thing to reconcile between those, is that we want to minimize tryptophan and serotonin, not good things. And we'll have a serotonin discussion, not this time, but in a future interview. But how do you reconcile that with melatonin? Is it the conversion that's the issue? Is there some crucial enzyme that's responsible for converting it? Because if you had low serotonin, you're not going to make melatonin.
Exactly. But here's the thing. Healthy people are known to have higher levels of melatonin. But the production of melatonin from serotonin depends on ATP. So once again,
it's ATP.
Yes, on ATP.
It's not the enzyme. It's just simply ATP.
Oh, no, it's a cofactor. But if metabolic rate is not good, if you're not taking niacinamide,
the bottleneck is ATP.
Yeah. So healthy people can convert, and actually, since serotonin is not good for you, there is a theory out there, hypothesis, that melatonin is kind of like the protective version of serotonin that puts you to sleep, because serotonin puts you into torpor, in a very non-restorative, kind of like shallow sleep. Hibernating animals have it; they're half awake, right? But they're neither asleep nor awake. So if you don't have the melatonin, you're going to build up serotonin, and that's really bad for your sleep and bad for your overall general health. Now, however, taking more melatonin, depending on, I think I will be really careful with the dosage, because I'm seeing supplements on the market selling 5 and 10, even 50 milligrams, where you're producing about 500 micrograms per 24-hour period.
There's people recommending 100, 300, 400 milligrams of melatonin.
Wow.
Yeah, I'm telling you.
I think that's obscene. So here's what happens if you take that excess. By the negative feedback pathway, you're going to be basically inhibiting the enzyme that converts the serotonin into melatonin, because the body says, oh, I have plenty of melatonin. Don't give me more. And our serotonin starts to build up. And if your monoamine oxidase enzymes are not working properly, and even if they are, if you build up a sufficient amount of serotonin, you're going to get terrible nightmares, which are identical to the nightmares that people with post-traumatic stress syndrome have. And they're known to be treatable by serotonin antagonists. So if you take too much melatonin, you will build up serotonin, and that's not a good thing. But if you're deficient in melatonin and you take a physiological dose to recover it to the point where you sleep well, you'll be in a better position than not addressing it at all.
That is magnificent. Exactly what I was looking for. Man, that is great.
And by proper dosages, so you sleep well through the night. And of course, hypometabolic people will have less melatonin, more serotonin. But if a hypometabolic person takes too much of a melatonin, they're going to raise the serotonin even more, right? And you're going to end up in a situation where they don't sleep well. I've taken higher dose melatonin, and the dreams are just absurd. And it's really, you wake up like shaken up.
Well, that's interesting, because I heard you say on another podcast that a common source of nightmares is high cortisol levels. So,
which activates tryptophan hydroxylase.
Yeah. Is that the reason it increases serotonin? I didn't know that was a mechanism.
They all go together. It's basically part of the stress field, which helps you survive at the expense of your functioning as an optimal functioning as a human.
God, this is so. I knew this would be an unbelievable compilation of material and knowledge that you're transferring.
Estrogen activates tryptophan hydroxylase while simultaneously suppressing tyrosine hydroxylase. So when you're under stress, you're going to have more serotonin, less dopamine. Conversely, when you're in a good health, happy, and gregarious, more dopamine. And dopamine is an inhibitor of tryptophan hydroxylase, so you're going to get even less serotonin. So really kind of like a feedback cycle. If once the good times start and you maintain them for a while, they become self-propelling. Once the bad times start and they continue for a while, they also become self-propelling.
Well, perpetuating.
Yeah. Perpetuating, yeah.
Yeah. So I'm sorry to correct you, but I am always impressed how literally 15 years ago, you probably didn't even know English, and you're so articulate and able to communicate these complex scientific concepts into material that we can digest and understand. It's just amazing. You're just an incredible human being. So one of the things we skipped over, and I think we have some time for now, is protein, because you're really cautious about certain amino acids, and I think rightly so. I think we need to keep that, the protein levels down that you quoted earlier, really pretty small. And actually, they're not, those are much lower than is recommended to build muscle mass. I mean, typically it's like twice that level, but you still want to keep the total dose down for most people below 120 grams a day. But I personally kind of shoot for 120, but you were advocating 80 or so. And that's interesting to know that, people could do well with that level of protein. But anyway, the specifics of the protein are methionine is well. So I want you to talk about the methionine, how it's well correlated with a decrease in longevity because it has some negative impacts. And then there's other amino acids like the tryptophan and cysteine that are problematic also. So one of the ways that you can address the methionine, because certain healthy foods like eggs and beef, at least the muscle meats, are high in methionine. So I personally add like 7-8 grams of glycine to my eggs and my beef to mitigate that methionine and balance it out. And I didn't realize glycine was an inhibitory amino acid. That's nice to know. But and then you also mentioned the branched chain amino acids, which is really good anabolic because it activates mTOR with leucine and isoleucine and the valine. But the branched chain amino acids can actually inhibit absorption of the tryptophan, I believe you said.
And methionine.
Oh, methionine. Okay, didn't know that. Okay.
And aspirin. Even another reason to take aspirin, it inhibits the absorption of methionine, cysteine, and tryptophan from the food.
Really?
Yeah.
So do you think that, and what type of dosages would it do that? Is it like...
Oh, probably just a single tablet, because the reason I found the study is that they were studying different type of phenolic molecules, which aspirin is a type of a molecule like that. And they found that they're widely distributed in nature, virtually a lot of food, especially grapes. Speaking of grapes again, but oranges, pears, apples, right? They have it, but they're usually in the skin, which a lot of people peel and throw out, but that's where actually most of the benefits are. So anyway, if you eat phenolics, a significant amount of them, and they're saying that the average daily consumption is in the several hundreds of milligrams daily, which kind of tells me that about the same amount of aspirin should probably have similar effects, except that it's taken as a single tablet versus spread out throughout the day, which is what the phenolics in the diet would be. So maybe take a baby aspirin with each meal, which would come down to slightly over 200 milligrams, and then you will be inhibiting a significant amount absorbing a significant amount of these inflammatory amino acids from the food.
Wow! So you think a dose as low as 80 to 100 milligrams of the aspirin with the meal itself would be enough to inhibit the absorption?
If you take whatever, let's say eating 3 or 4 times a day, that means about 250 to like 300 milligrams of aspirin daily, which is about the same as the amount of phenolics we will be consuming from the food. And by the way, we're still consuming those phenolics. So all you're doing is you're augmenting. Yeah, exactly. Yeah.
So, wow. So what do you think is the ideal dose of aspirin for most people? And are there specific subsets of individuals who would benefit from a higher dose?
So for they call it primary prevention, right, of cardiovascular disease, the baby aspirin is probably enough. For cancer prevention,
wait, let me stop there. Is there a dose of the aspirin that is optimal for blood thinning as opposed to other metabolic?
Yes, methods? Lower doses, paradoxically, of aspirin basically prolong they increase the prothrombin time, which means they thin the blood and make you more prone to bleeding. A lot of research has been published trying to demonize aspirin and how it increases your bleeding risks and whatnot, and a lot of doctors are not recommending because of that. But I have multiple studies showing that aspirin prevents you from dying from severe bleeding events in the gastrointestinal tract and the brain, which is precisely the reason most doctors are saying don't take aspirin because it can kill you from a bleeding stroke or like a bleeding in the gastrointestinal tract. In a higher dose of, which means a regular tablet, 325 milligrams or higher, aspirin actually decreases those risks. So you can think of it as a bleeding modulator. At a lower dose, it will thin the blood and maybe prevent a heart attack, right? But at a higher dose, basically, it still prevents the heart attack, but not so much through the coagulation mechanism, but because probably of the prostaglandin inhibition and reduction of inflammation in general, which is well known to be the primary cause of these plaques that are causing the heart attacks to start with.
So it causes it blocks it at a more fundamental level.
Exactly. Prevents them from happening versus you already have the plaque, right? You're concerned the plaque will rupture and plug a vessel, right? Then the small amount of aspirin, the baby tablet, is probably the best way. But to prevent those plaques from forming, I think the higher doses of aspirin, like just a regular tablet, and by the way, not every day. For cancer prevention, a study showed that if you take aspirin 3 times a month, it's enough.
Wow.
Yeah. 3 times one tablet, 325 milligrams. Couple of times a month, 2-3 times a month, I think was was enough.
But I don't think that's optimal. I think
it's not optimal. No.
No, but it will provide some benefits. So that's relief in case for those of you who tend to forget your supplements. But for someone who's really interested and can really be compliant with any regimen, what do you think for someone who's healthy the dose of aspirin should be?
I will take a regular tablet of aspirin daily, and if you skip a few days because you forgot, which comes down to, let's say, 5 days out of the week, it's probably enough.
Just one a day. Okay.
Yeah, one a day, exactly.
And potentially divide that up. I kind of like the powdered aspirin. It comes with a little scooper, and each scooper is like 100 milligrams. So you could take that with each meal.
You could take it with each meal, or like make yourself a nice solution of, let's say, orange juice and aspirin dissolved in it. Maybe heat it up a little bit. It'll be a little tangy, even more, and drink it throughout the day.
Do you think there's any benefit to taking it at night before you go to bed? Because you said it inhibits lipolysis, and I'm wondering, you're fasting essentially at night. Hopefully, you're sleeping for 8 hours, so it's an 8-hour fast, and the tendency is for your glycogen stores to become depleted. But my guess is, if you're healthy, you've got enough glycogen in your liver where that's not going to be an issue.
But if 70 to 80% have liver disease, their glycogen level stores are terrible. So aspirin is great for improving sleep.
Would that be better? So here's my proposal for an optimal for most people is to take maybe 100 milligrams or baby aspirin with each meal that has a lot of protein, and then before you go to bed, take 1 aspirin to inhibit the lipolysis.
So basically, if you're taking it throughout the day, you probably don't need to take it at night because aspirin metabolizes into salicylic acid. And salicylic acid half-life is like a 30 some odd hours of half-life. So you'll be okay.
It doesn't matter. Okay, so this is a refinement. So you also posted a study on your blog it was from New England Journal in January of this year, where I think the dosage was a baby aspirin twice a day was equivalent to or subcutaneous heparin for clot prevention. Yes, in a surgical.
They call it non-inferior. I love this term.
That you know what that is? It's because I went to medical school. You know what that is? That's a double negative.
Yeah, exactly. So the confused is like, what do you mean by non-inferior?
It's totally fucking confusing. Yeah.
People remember the inferior, so they're saying, "Oh, aspirin and inferior in the same sentence. I'm going to go with heparin."
Yeah, right? That's what they love doing that. That makes them think that makes them look smarter.
Yeah. But I think it's a thinly veiled attack towards aspirin by trying to put into people's minds the idea that, look, aspirin is for grandmas, it's an obsolete drug. We have the modern nice stuff now, which, by the way, did I send you this article that the Xarelto trials were fully fraudulent? Not wrong. Fraudulent.
Which trials?
Xarelto, which is the flagship blood thinner that they use now for like AFib and for preventing strokes, is XAR.
What's the brand name of it? Is that
Xarelto? Is the Rivaroxaban is the name?
Oh, geez,
Xarelto is the.
I've never heard of it. I don't prescribe these drugs. So I don't know.
Yeah, they're not. So they moved away from heparin to the Xarelto type of drugs. But then there was an article in Slate.com, which is like a really kind of like an investigative journalism magazine. Used to be much better than this now, but anyways. So they said FDA, most of the clinical trials were done in Mexico and other places. FDA knew that the trials were fraudulent. They weren't simply substandard. They was based on made-up data. It still approved the drug. And when the journalists started questioning the FDA, why did you approve it? FDA said, if you don't stop questioning us, we're going to throw you in jail. I don't know how that works, but anyways, aspirin is non-inferior to any of these blood clotting drugs. I don't want to say superior because the FDA will come up to me and say, who are you to make health claims?
So it's not irrational, if your doctor, because this is a common scenario, as I'm sure you're aware of, people who have a stroke are put on prophylaxis or have a stent for a coronary bypass, or they're going to surgery like the study did, that they're going to be put on this DPT prophylaxis, and they usually use heparin or these other Eliquis, I think is the other one that's
Eliquis.
Eliquis. So, which seems to be the more common one now. So, and then Plavix.
Yeah, Plavix.
Plavix, yeah, which is interesting. There's a woman who is an MD PhD out of Stanford, Barbara Starfield, and I wrote an article based on her studies she published in JAMA in 2000, July 2000, 23 years ago now, that I abstracted from it the meme, the doctors are the third leading cause of death. And that was actually my meme that I created. And the irony and the reason I mentioned here is that she died 11 years later in 2011 from taking Plavix, which is a
from a bleeding event.
Yeah, it's from Plavix. So she died from the very article that she helped promote. The doctors with the leading cause of death. So anyway, the point here is that there's a lot of options out there, but Plavix being one of them. So you think that it's reasonable and relatively safe to consider a baby aspirin once or twice a day?
I don't know of a single person who died of taking aspirin. I mean, I've looked at the case studies.
Well, but I mean,
I've scoured PubMed.
But it's not the diet of the aspirin. The concern is that going to be enough of a prophylaxis to prevent dying from the stroke or a clot somewhere?
Absolutely, yeah. Basically, to this day, I don't know of anything that provides the same benefit as baby aspirin for primary prophylaxis while having equal or fewer side effects. Nothing come close to aspirin, except possibly vitamin E, which is very similar in its effects.
So another supplement that should be taken pretty much by everyone every day is vitamin E. But there's a lot, we talked about this in our first podcast, actually, our first interview, is that there's some specifics you got to be careful of. Like the dose isn't really high. You want to get the right stereoisomer, which is the dextro, not the levo. So you don't want DL or the racemic version. And you want primarily alpha because there's alpha, beta, gamma, delta. You want primarily alpha. So you want all isomers and you want that. And you don't. And you want some tocotrienols, but not as much. It's mostly D-alpha tocopherol. And small doses too. I mean, not 400 units. We're looking at like 100, 150, somewhere in that range. And then I remember that you did a lot of work on this. You actually came up with a vitamin E supplement because based on Ray Peat's work, because Ray Peat was doing his work on, he was a big proponent of vitamin E, but it was a very specific vitamin E, one that was extracted from wheat germ, which doesn't exist anymore. And wheat germ has some problems. I forget that. I think it's really
62% linoleic acid.
Yeah, I was going to say it's really high in linoleic acid. Yeah, so you don't want to take wheat germ oil. That's for darn sure. But in small dose, that's a confusion too, because like our vitamin E supplement is from sunflower, and sunflower is really high in linoleic acid too. But people say, oh, you can't. It's not linoleic acid. Well, it might have like a few milligrams.
Yeah,
it doesn't have 20 grams.
Yeah,
a few milligrams is not going to hurt you. It's probably less than 1% of linoleic acid you take in a day. So anyway, that's a diversion. But a lot of people have questions about some of the supplements and if they have a seed oil in there, or because you got to get the vitamin E from somewhere. So it's typically from a seed oil.
Yeah.
That's where they're at. You're not because you don't want it synthetic. You want it derived naturally. So are there any other pearls in vitamin E, generalizations that you can make on how people need to consider taking that as a supplement? Because I think almost everyone benefits, largely because it's going to limit the oxidation of the PUFAs to the dangerous metabolites like malondialdehyde, like 4-hydroxynonenal, the things that really cause the damage. So it's not that the omega-6 linoleic acid is dangerous by itself. It's the metabolic byproducts, the degradation products that are so toxic. That's what kills you.
Yeah. And linoleic acid, by the way, even its non-peroxidized form acts very similarly to estrogen because of its unsaturation.
Oh, I did not know. Leave it to you to leave another pearl. I did not know that.
And increases the permeability, the fluidity of the bilayer lipid membrane, and all sick cells, especially cancer cells, are known to have drastically increased membrane fluidity.
Yeah,
they're very easy to permeate in and out. So that's not a sign of.
Well, and then we talked about earlier cardiolipin. If it's one of those fatty acids in the tail, it's going to increase the likelihood of susceptibility. And my guess is once it's in the mitochondria, it's going to contribute to that reverse electron flow, which is going to shut down metabolism and increase reductive stress.
Yeah. So if you damage the cardiolipin because it's got a lot of PUFA, so it gets peroxidized, cardiolipin cannot bind with the complex 4, so that complex is now dysfunctional. Even if all the others are working, then you start getting a buildup of electrons, and eventually basically the mechanism says, okay, they can flow in only one direction now, backwards, right? Because forwards is blocked.
All right. So you revised yet another concept they had about linoleic acid, that it is toxic in and of itself. It's not just the metabolites, which are, what do you say is worse, just the linoleic acid by itself or the metabolites?
The metabolites are worse, definitely, because they're directly mutagenic and carcinogenic.
Okay.
However, linoleic acid itself is dangerous in a very pernicious way. By itself, it doesn't directly immediately cause problems, even though it can get metabolized into the arachidonic acid and then the prostaglandins and leukotrienes. This process takes a little time. But linoleic acid by itself, because of its structure and the multiple double bonds, synergizes greatly with estrogen. So you can actually in animal models, cause cancer by injecting physiological doses of estrogen that normally would be even healthy. However, if they're combined with a sufficient amount of unsaturated fats, I think they tried linoleic acid mostly, but other saturated fats did the same thing. Linolenic was also not as pro-carcinogenic as linoleic, but still similar. And the EPA and DHEA,
omega-3, 18 carbon.
Yeah, omega-3 were actually the most carcinogenic, but they had the side benefit, quote unquote, that they peroxidized so quickly they couldn't exert their cancer potential quickly enough. But their peroxidative byproducts were also carcinogenic, so we're still getting the benefit. So yes. so
vitamin E will protect that.
Exactly, vitamin E will protect that, and also vitamin E has been shown to also have an antagonistic relationship with estrogen. The name of vitamin E, one of the common names is tocopherol, which means pro-fertility, right? In Greek. So they knew back in the early 20th century, even before that given people, at the time was wheat germ oil, but it's very rich in vitamin E, that it can actually improve fertility in both males and females. Subsequently, it was found that vitamin E is the main factor for that, and it's capable of binding and blocking and acting as an antagonist at the estrogen receptor alpha, and it's also a moderately strong aromatase inhibitor. All of the tocopherol isomers, not so much the tocotrienols. So basically, by taking vitamin E, whatever estrogenic effects are out there, even from non-peroxidized PUFA, or if you're producing too much estrogen for whatever reason, if you have endocrine disruptors, which are capable of binding and activating the estrogen receptor, just as like estrogen does, tocopherol will block some of that as well.
Wow.
It's really a versatile molecule that has genomic steroid-like effects, but it mimics progesterone, which is also the main anti-estrogen in the body for females, testosterone and dihydrotestosterone being the main anti-estrogens in the body of males. Tocopherol will have most of these effects, and it's probably much fewer side effects than taking steroids. And the daily needs have been shown to correlate perfectly with your intake and also storage of polyunsaturated fats. So the daily need, real RDA of vitamin E is about 2 milligrams of vitamin E for every gram of PUFA consumed.
Wow.
Which means if you take in 50 grams of PUFA, you need 100 milligrams of vitamin E to combat basically its peroxidative potential and also estrogenic potential as well. So most people are used to measuring the vitamin E in units, and basically if you take the vitamin E dosage in milligrams and multiply by 1.5, you're going to get the dosage in international units.
I only have like 5 or 6 grams of PUFA a day. So I would only need like 10,
what is it, 5 or 6 or so, less than 50 milligrams of vitamin E daily, which is like 20-30 IUs a day.
Is there any danger taking a higher dose than you need?
Well, it acts like aspirin. It can thin your blood to the point where it basically could become a problem. But I've never seen a person there's these famous researchers in Canada known as the Shoot brothers, and they were treating people with vitamin E, massive doses. I think like 7-8 grams of mixed tocopherols daily, and they were treating them from diabetes, heart disease, various other different conditions. And based on their publications, some of which are peer-reviewed, not all, I don't know of a single case of a person who had like a serious negative experience with vitamin E, but it does thin the blood. So, it may prolong bleeding time.
Okay, perfect. Wow, that's really, really helpful.
And since estrogen clots the blood, I think we can actually use that little bit of extra vitamin E.
Yeah, the other thing too is that vitamin E is a fat-soluble vitamin, which means it's stored in fat tissues. So you don't have to take it every day, right?
Yep, and that's the good thing because most of the PUFA is stored, right? If when you eat a meal that has a lot of fats in it, they're usually a mix of monounsaturated, polyunsaturated, and saturated. Ideally, it should be mostly saturated, but let's say you're eating a mixed meal, the saturated fats, because they're more easily passed through the process of beta oxidation, they're preferentially oxidized. The monounsaturated and especially the polyunsaturated are predominantly stored in the fatty tissue, which means that most of your fat stores are PUFA. That's exactly where you want your vitamin E to go to protect that PUFA from getting peroxidized.
Where it does go when it's absorbed, it goes into the adipose cell and next to the PUFAs?
Yes, it goes precisely into the and actually it can build up in the lipid bilayer of the cell, which is basically going to be made mostly of fats. So that's where it needs to be in order to prevent the reactive oxygen species from damaging it. Yeah.
Wow. All right. But so that's good because you won't have the dangerous metabolic byproducts, but you still don't want PUFA primarily because of the reductive stress.
The reductive stress and also the PUFA itself being estrogenic and anti-metabolic in general and pro-inflammatory.
Do you think the reductive stress from the PUFA is the primary reason for obesity?
Yes, they're the primary anti-metabolic factor in our diet that changed dramatically over the last 100 years.
That's what I thought. Yeah, okay.
Plus the endocrine disruptors, which act remarkably similar.
Yeah, it doesn't help.
So let's go this way. PUFA is an endocrine disruptor of natural origin. We have other ones.
Beautiful, absolutely beautiful. So would you include glycine as an essential supplement nutrient like vitamin E and the niacinamide and aspirin?
Glycine together with methylene blue are the only two ingredients that I've seen showing full reversal of the aging phenotype in human cells, but it was in vitro studies.
What type of dose? I mean, because clinically it seems like you need grams. I'm talking
millimoles.
5, 10,
Yes.
10, 15 grams per day.
The dose, the study that I showed in vitro, I think showed 3 millimoles per liter concentration, which in humans is achievable by about 10 to 12 grams of glycine daily, which means 2 tablespoons of gelatin will probably do it.
Okay, perfect. Yeah, because I mean, gelatin's like 1/3 glycine, I think, because the rest is proline and hydroxyproline. So that's another good point. Thank you. Good segue. I didn't have that on my list, but I think this is another one of the essential supplements people should be on that we're pretty much all in agreement. Niacinamide, no question. Aspirin at the dose we just discussed.
Methylene blue.
Well, then methylene blue with the cautions if they're taking SSRIs. Methylene blue for sure. I think it's not that one's better than the other. You need them both. Methylene blue and niacinamide is a 1-2 punch unless you're taking SSRI, no methylene blue. Or get off the SSRIs, and you can with the strategies that we talked, because it's, when you're coming back, we're probably going to talk about serotonin and cancers and stuff. But serotonin, it's easy to control it once you implement these strategies. Maybe not easy, but the strategies are there and they work. They're effective, and you don't need drugs to modulate your serotonin. Although you have some really interesting, I have not gotten into the supplements you sell on your site now, but it's like you've got it's a wizard's apothecary. You've got like these that don't exist anywhere else in the world that you created in your lab, that you need like a drop or two of these things, and it's just like, oh my gosh! I just got the 5. Talking about serotonin, it's the
10-methoxyharmalan.
That's methoxyharmalan, which is like essentially an analog of LSD that which worked on serotonin, right?
By the way, it's a metabolite of melatonin. We produce it internally. It's a direct metabolite of melatonin.
I did not know that, but it seems to be fairly effective. Like 1 to 3 drops a day for someone who's on an SSRI, and then get off the SSRIs.
Yeah. So if you look at the molecules, serotonin, melatonin, and 10-methoxyharmalan are almost identical. Basically, the melatonin molecule with an extra molecule of hydrogen becomes 10-methoxyharmalan. And because they're so structurally similar, they can bind to each other's receptors. Serotonin having 7 receptors or more that we know of. Melatonin, I think, having like 3, M1, M2, M3. Oh, another reason I forgot to mention, the reason I'm a little bit wary of taking more melatonin is that some of the newer, very successful antidepressant drugs that are still in animal research are melatonin receptor antagonists. So there's something about melatonin at higher dose, which I think is expected. It puts you to sleep, but a really deep sleep. And the way it does that, it lowers the oxidative phosphorylation in the brain, which can be helpful at night when you're not active, right? You want to be asleep, you want to recover, you want to be careful, and you want to spare as many resources as possible. It's not good during the day. But people that are basically depressed, they're known to be sleepy. They're known to be tired all the time, and they're, fatigued and whatnot. A lot of it is from serotonin, but if you have high serotonin, this means that by extension, probably they're going to have elevated melatonin as well. So
it's anti-metabolic.
Yeah, it's anti-metabolic, exactly. Yeah. And they found out these drugs also, which we kind of expected, they relieve depression, but they also increase the metabolic rate, which to us is one and the same, right? So depression is a sign of low ATP production. Study with insects, I know a lot of people say, well, insects are not humans, but it was replicated in rodents and various other animal models, demonstrated that basically there's a spectrum, continuous spectrum between very good health and really violent homicidal aggression at the other end of the spectrum, and it's all controlled by ATP levels. 20% drop of ATP levels in the brain will make you depressed. Another 20% will make you almost comatose. And then another 20% will get you to a really violent, aggressive phenotype, which, by the way, the SSRI drugs have been shown to cause. And what do they do in the brain? They lower the levels of ATP. There's some revelations that are going to come out soon about SSRIs. I think people know about them, but I mean in the legal system, people are going to start suing. Some of the mass shooters are the victims of the mass shootings have banded up together and said every single mass shooter in the United States has been on a psychotropic drug. 90% of those cases have been one or more SSRI drugs. It cannot be a coincidence.
Yeah, then I think you mentioned several times, I think it's still in phase 3 clinical trials. Pfizer's coming out with a new drug that's a serotonin antagonist.
Yes, Tergoride. Yeah, for treating cardiac failure, which they up until even now medicine says is irreversible. It's a progressive condition which eventually kills you unless you get a heart transplant, or pulmonary fibrosis, which is also terminal, and you usually cannot get a transplant for that. So they're saying Tergoride, by blocking the serotonin receptor 2B, is able to not stop, reverse the fibrosis.
Interesting. Wow. We're going to dive deep into that later, but I've got a question, just a curiosity question. I'm sure you know the answer.
Sure.
With a popular biohacking intervention that I'm not too fond of. I've tried it initially, but it's very painful. It's something called cold thermogenesis, where you jump into an ice bath. Would be sort of the extreme, but certainly you can use lower temperatures, 50, 60 degrees even. Obviously, if you're in an ice bath for too long, you could die. But the reason that many people encourage it or recommend it is because of an increase in dopamine. And it just seems to me not a wise strategy, but maybe I'm confused. And I'm just really curious as to what your take on is from a metabolic perspective, and if there's any harm or damage.
Of definitely harm, and your intuition is almost on the right track. It evolved for 4 billion years. I think if we listen more to our intuition, of course backed up by data, it's better than simply following some abstract reasoning. So the reason first of all, cold thermogenesis, it raises your not the baseline, the peripheral temperature by increasing the release and synthesis of adrenaline. Now, of course, it's going to raise your dopamine first, because dopamine is the precursor to adrenaline. But it seems like a rather torturous way to basically, first of all, you're going to raise dopamine, but not much will stay as dopamine, because you will quickly get converted to adrenaline. And that's what converts the white fat into the brown fat. And the brown fat is more metabolically active. And the proponents of cold thermogenesis say, hey, these fat cells are going to burn more calories. They're going to consume more of its own fat. So it's great.
Yeah.
That's what they do.
Yeah.
But guess what other condition has the exact same process? Metastatic cachectic cancer. Patients with cachexia have almost no white fat left. They're almost entirely brown. And first of all, they lost a lot of it. They look gaunt, right? But the exact same process, driven by adrenaline, is implicated in the cancer, in the cachexia of cancer. That is an exact same process in cold thermogenesis. So it's a stressful response. Why on earth would you want to cause yourself more pain? Now, no pain nor gain. I can kind of agree with it, but it does not mean that more pain is going to give you more gain.
So you don't think it's really good for anyone then with that answer? It might sound like.
I would say it would be better if you moved to actually a very warm environment, high up in the mountains.
I live in Florida.
Yeah, exactly. Florida, and you're going to be burning more calories without stressing yourself to the same level. Now, extreme heat is also a stressor, but not nearly as dangerous as extreme cold.
It's not extreme heat. And then they've got these AVAs, these arteriovascular anastomoses in the soles of your feet and the palms of your hand on your forehead. So that if you're walking in on the beach and your feet are in the ocean, you're dissipating all the heat. So you have no issue with heat stress.
Yeah,
zero.
It's like elephants. They have big ears for only one reason. That's their dissipating mechanism for heat.
Yeah, for sure. So, yeah, and I live in Florida, but I live in north central Florida. So it gets too cold here in the winter. You can't go in the water. So I go south. I go to Central America or Mexico.
Really, Florida gets so cold that it cannot go into the ocean in the winter?
Well, you could if you want to do cold thermogenesis. Yeah, the water goes into low 60s, high 50s for sure.
Oh, wow.
Now, South Florida is probably not as bad, but it is up here. So I just don't go in, So it's like 6 months out of the year you go in. I mean, it's like in the mid 80s now, which is good. But, oh, man, that is good stuff. Did I want to follow up on it?
Cortisol? Should we talk about cortisol?
No. I get no. Just finishing up with cold thermogenesis. So that the conclusion I had reached prior to your comment on this, which is different now, but was that it was okay for people if you were young. They could tolerate.
Oh, sure, they could tolerate.
They have much more resiliency and reserve than the average person. So the intuition was spot on, but it really isn't good for anyone. Which is interesting because there's so many people. I mean, there's a lot of leaders in the biohacking space, and they're almost every single one of them are strong advocates of cold thermogenesis.
One of the established methods for aging animals prematurely is to expose them chronically to extreme cold.
Yeah, and the other thing they don't get is that cortisol elevation is the primary reason. That's what every strategy should be directed at lowering cortisol. Mm-hmm. So what are your thoughts on meditation as an effective way to lowering cortisol? Because there's a lot of people who recommend that.
The expert meditators have been shown. I've seen studies with the monks in Tibet and whatnot. They're really good at controlling their physiological response, but that takes decades of practice. Okay. I think for a lot of people, it's become a fad. And I posted a study showing that if you're an inexperienced meditator, and basically you're doing this for several years, and if you have some mental problems that are not addressed, meditation can make them worse. And in fact, apparently it was well known among the meditation community. They call this coming to Christ moment, or you kind of like you're facing your problems without any bias and somehow working through them. However, that study several studies I posted on the blog showed that in some people, meditation actually could generate mental health problems de novo. They got mentally ill by meditating, especially the more extreme forms of meditation that practice like extreme fasting or like under extreme temperatures or in extreme environments. But I think meditation just as like aspirin or methylene blue, if you know what you're doing, and there are not many people that do that, or at least paying attention to what you're doing, it can be helpful. But it's not the cure-all that is being presented, and I'm kind of concerned it's becoming another fad. Everybody that I know around me says, "Oh, you're under stress? Meditate." Well, I mean, if I'm working a toxic job, or I have I'm surrounded by toxic people, meditation is not going to address that. It's just another Band-Aid, right? You have to always work for the ultimate cause and try to resolve it. Granted, sometimes it's not easy to resolve, so you kind of have to Band-Aid sometimes. There are things that are, let's face it, there are things that cannot be directly resolved. But for most things, go ahead.
It would seem to me you can modulate a lot of the stressors if you focus on increasing your metabolic rate. And
precisely. It will be a much more direct and physiological way.
Because once your cortisol level goes down, doesn't the stress decrease? Of
course, by definition. I mean, the primary feeling of agitation and nervousness and basically the fight or flight response, that's driven by cortisol. That is its primary role to kind of keep you alive, whether it's somebody chasing you, like a saber-toothed tiger a million years ago, or you're in an office with some toxic people and somebody is yelling at you for no reason. The exact same situation. Basically, the body perceives this as a threat and says, okay, since you're not eating right now, right, I need the energetic resources to handle this threatening situation. Where are these calories going to come from? From your body.
Well, I've exhausted my questions for now, but I'm definitely going to have you back. We have to have a really long discussion on cancer, because that And I know you've done some original research in animal studies, and you've got some really novel approaches that absolutely conflict with my previous understandings and people I've interviewed in the past who are experts. So I'm really looking forward to that discussion for sure. But I can't thank you enough for your commitment, your dedication, your knowledge, your willingness to share all the time and provide such a wealth of knowledge and information that's going to radically change people's lives. So you're beyond awesome. You took like few months off this year because I don't know, you were busy or something. But until May,
I'm a government contractor. I think I told you. And when there's a project, I get sent to the client side on a government agency, and I basically all day there. When I come back, I have family to deal with, so it's not exactly. But these articles accumulate, so I read on a daily basis, but I just can't post on a daily basis. So
it's a lovely resource. I'm so glad you compiled it. So, all right, so that's one place for you, and then. We'll keep posting.
That's pretty much. I'm on Twitter as well. Twitter.com/Kado.
Twitter is there anything on Twitter aside from your blog posts?
I mean, sometimes I interact with people. They send me some interesting studies, and I comment on those too. So it's like
what's your Twitter handle?
Same as the blog Haidut, Haidut. So Twitter.com/Haidut.
Okay, perfect. All right. Well, thanks so much, Georgi.
Appreciate it. Always a pleasure. Great honor to be on your podcast.
Thanks so much for watching. Remember, hit the like and subscribe button so you can get more videos that can help you and your family take control of your health.